to narrator Wyatt.
Thank you.
Gosh, Slade. Well, happy early birthday. Great. Synthetic division. We're gonna go back, hit on a couple of things quickly and review, and then we will come back and pull it. Oh my gosh. Remembers, huh? Not yet. All right. We can only use synthetic. We can only use synthetic when we're divided by what?
An X and a number.
An X plus a number or minus a number. No leading coefficient, no exponent. And we set it up with the upside down division sign, right? But we have to be careful to remember what? What do we need? What? Placeholders. Thank you, Emma. Okay. Oh my gosh, y'all, what is going on today?
Just keep talking, Miss McGee.
No, I can't. I am entirely too ADD for that. I'm going like, okay. I need a third placeholder, right? A power of 3. I've got 4. I don't have 3. I have 2. I have 1. I have a constant. So whenever I set this up, outside of the division sign, what's the number? 1. I'd have to change that sign, right? And then I have 1, 0, 3, 4, -1. This should already be done on your packet. This is the very first one there. Drop it. Multiply, add, multiply, add, multiply, add, multiply, add. Interpret that answer. That means whenever I divide here, what do I get? Ooh. Because 7 is my what? Remainder, and 7 is always my remainder. Now, we talked about before we left. Where? Yeah. There's one in every crowd. Are y'all fussing again? Okay. What happens? What happens if you plug in 1 here for every X and you get 7? That is the remainder theorem. The remainder theorem says because if you get 0, you know there's no remainder, which means it's what it starts with an F factor. F of any number that you put in.
The remainder of divided by this number is so much easier to just do the synthetic division and get over.
I'm going to use K. All right. If I plug K in here and I get some value R, all right, that means if I divide f of x by x minus k, the remainder is R every single time. In other words, it doesn't make sense. Here, f of x was x to the 4th plus 3x squared plus 4x minus 1. F of 1 is 7. That means that f of x divided by x minus 1 has a remainder of 7. Oh, dear Lord. Okay.
Is that right or wrong?
Yes, but the point is you can do it either way. The remainder theorem says when you plug a value in, it gives you the remainder. No, it's basically not one thing.
What you're saying is we can either do everything in purple or just circle 7.
That's red.
Or pink. Or just circle 7.
Red is fine.
Okay. Now, what we also know is that if you get a remainder of 0, that means that you found a, say it again, that's right, found a factor. And in fact, when you divide by a factor, you get no remainder, but you get what? Your answer is another factor. Dividing by a factor gives you another factor. Yeah. Dividing by x minus 3. Plugged in a 3. Yes, that would give you the remainder. All right, is everybody okay? No. Okay, where are we not okay? Are you upstairs?
I'm perfectly fine.
Okay.
They weren't paying attention to
Dividing and giving you a remainder of 0 means you found a factor. Would you agree? If I take anything 6 divided by 3, I get 2 with no remainder, right? So that means this is a factor, but 2 is also a factor. Okay, that's all I'm saying here. When you get a 0, you got a factor. 2 factors could also, these 2 factors could multiply together to give you to what you started. Right? So in other words, dividing is another way to factor. Okay, remember whenever we factored quadratics into 2 pieces? This is another way to actually factor, is by dividing. That's all you know. Okay. So that brings us around to number 7 on your packet. So everybody flip to number 7. I feel like we did number 7. Did we do number 7?
I did 7. We did 7.
Then the bell rang. Okay, let's go with 7.
Then you told us that we didn't have to,
I've done 7.
oh wait, no. We did finish. We finished, I think. No, we didn't.
You said we could go ahead if we understood.
Yeah, but you said we would have homework.
So there are 1, 2, 3, 4, 5 of them. I'll do 2 of them. That leaves you 3 for homework. All right. I'm going to do 7, and then I'll do another one. Okay. All right. So can you steps, right steps? There are steps over on the other side there of how. I didn't. Oh, that's right, because I said come back to it. Because you got very angry about that. Okay.
Because you were saying stuff and they weren't going into that one.
Boy, y'all are a tough crowd this morning. Okay. To find all the other factors, which is the directions here, it's factor completely given one factor. Well, if I'm given a factor, I can easily find another factor by doing what? Somebody said it, dividing. Okay? Dividing by a factor gives you another factor. So what I want to do is I want to divide by this factor first. And because all of these factors are in the form of x plus a number or x minus a number, synthetic is going to be A-okay for me here. So outside, I put a -5. Remember placeholders? How will, yeah. How will I know if I've done this correctly? That's exactly right. If you don't get a 0 in that very last column, you have done something wrong, because literally the problem said, hey, This is a factor, and by definition, that means if you divide, you get no remainder. Everybody okay there? All right. So, all
We have 2 or 3 problems.
in this section. Okay. Y'all are so whiny today. What is going on? I was going to say, we got pretty far. It's not, the packet's not extensive. Okay, that means that f of x, this is f of x, divided by x plus 5 gives me x squared plus x minus 6. Again, if you get a remainder, you did it wrong, okay? That doesn't mean you can never get a remainder when you divide by something. It just means if you divide by a factor, you should not get a remainder, okay? Now, the point of this was to factor completely. I know that whenever I divide by something, I can take what I got when I divided and what I divided by and multiply them together, right, to equal the same thing. So in other words, x squared plus x minus 6 times x plus 5 is actually the same thing as x cubed plus 6x squared minus x minus 30. Does everyone agree? Same thing as 6 divided by 3 equals 2, and 3 times 2 is 6. Just like that, I can multiply these two things together. Well, now can you factor completely? Sure, because this is a quadratic, and we spent a whole long time factoring quadratics. What multiplies to negative 6 but adds to 1? 3 and 2. This is a shortcut one because there's a 1 in front. So x plus 3, x minus 2, and the x plus 5 is still there. So whenever it says factored form, here is my fully factored form. I cannot factor any of those parentheses down any further. Is everyone okay? Now, the next line asks me for zeros. That's just factored form. That completely factors my polynomial, which was a cubic to start with. So how do I find the zeros if I'm in factored form? There you go. Set each one to 0 and solve. So when this one goes to 0, that means x equals, and x equals 2, and x equals. So would you agree with the fact that if you're given a factor, you are also given a 0? Because if x plus 5 is a factor, that means what is a 0? Negative 5. Okay? Very, very, very important. Let's skip over to number 11. Same scenario. Oh, let's do 10, not 11. It's a quartic though, so I want to show you what happens. All right. X minus 3 is a factor, which means if I divide, I should get 0, but I'm asked to 1 factor completely and 2 find all the zeros. So factor completely we shall do first. So to factor completely, I'm first going to divide by the factor given, right? So what goes outside? 3. Inside, give me my setup. 1.
3 plus 0.
Ooh, there you go. 0, 27. Oh, notice this is a quartic this time. And I better get 0 for my remainder because it told me that it was a factor. So 1, 3, 0, 0, 0, 0, 27, 81, and 0. Nice. So write this in factored form. X cubed plus 27. Now it said factor completely. Is it factored completely? No. Why?
Because the first one is the
Sum of cubes. How do you factor a sum of 2 cubes?
It's x plus 3, and then x squared minus.
Same change plus. I'm going to fill in my signs first. Same change plus. What times itself 3 times gives you x cubed? What times itself 3 times gives you 27? 3. And those are what I'm going to use to fill in my next set of parentheses here. Do y'all remember this? Y'all are doing the squint at the board right now. Restart. Little parenthesis, big parenthesis. Same change plus. What times itself 3 times gives you x cubed? What times itself 3 times gives you 27? Now use those to fill in the trinomial that follows. X squared together, square the n. Now it's factored because I can't factor this any further, right? It looks very similar to a perfect square trinomial, but in fact it's not because it doesn't square dance, right? That middle term's not doubled. You don't see that? So how do we find the zeros? Haney wants to know. Make them all 0. Okay, well that's easy enough here. X equals -3, and easy enough here. Oh, but I have to do the quadratic formula. In fact, with any sum or difference of cubes, I am going to end up having to quadratic formula that polynomial that follows that trinomial. So, opposite b plus or minus the square. I'm dead serious, White. Can you believe it? B squared minus 4 times a times c all over 2a. I see an imaginary solution on the horizon. 9 minus 36 over 2. 9 minus 36 is what? -27, and oh, you might think you're done, but you're not.
Yeah, no.
27 is going to be 9 and 3, which is 3 root 3. But there's an I on there, you're exactly right. So I got 3.
3 plus or minus 3i.
How many solutions is that? 2. Plus 2 more, which gives me how many solutions? How many was I supposed to get? Those are zeros. Zeros are 3, -3, and that. Yes. This one is factored form.
Wait, that's factor form. Okay. Then why do you quadratic formula?
To get the zeros. You have to set each parenthesis to 0 to get the zeros.
Why can't we just get a perfect square trinomial?
Why?
Yes. Why can't you make the sum halfway equal?
Sum and difference of 2 cubes are never easy. All right, flip back over to where it says factor theorem. We're going to fill in why it explains form now that we know a little bit more about it.
What is synthetic division?
All right, see if you can answer the questions now. Knowing that the remainder is 0 is very useful. When you divide a polynomial by x minus a and get a remainder of 0, then x minus a is a factor of the polynomial.
We've already done 2 of them.
Flip over to the back of the first page.
We just need the 3 ways to determine if x minus a is a factor.
The quotient is also a factor.
Yep.
When you divide by a factor, you get a factor. To factor completely, divide by a factor, write as a multiplication problem in order to finish the factoring. This allows us to find all the zeros, aka roots or solutions. And there are 3 ways to determine if it's a factor. Give me one. Division. Well, so since it's x minus a, I could do synthetic or long division, right? So those are 2. And if I get a remainder of 0, then it's a factor. So long division, remainder 0. Synthetic division, remainder 0. Yeah, because that's the only, if you didn't get a remainder 0, it wasn't a factor to start with, right? This is how to determine if it's a factor. What's the third way then? The one where Haney got so upset he stormed the board to say, so you mean to tell me? Which does what? How do you do remainder?
Finds the zero. Oh, the remainder.
What?
The only way to find this remainder already.
If you plug A into the equation,
Is that the answer?
look at what it says. Y'all, come on. Y'all, think about this. It says, is x minus a factor? Synthetic division with a remainder of 0. Long division, remainder 0. Or if you plug in A and you get 0, it is a factor. Plug in a 0, you get.
Wait, what? F4 equal.
I did not do this.
Yeah, you have
What's the deal? 5 and 5. Whenever it says F4, does that mean you put 4 in as X?
Yes.
Oh,
Isn't the remainder
What?
what do we notice on
there wouldn't be a remainder because it's a 0.
We noticed that we got the same value as the remainder in number 1.
what the remainder is?
Okay. I'm going to get through this next little section, give you a brain break, and then we're going to put everything together for PRZs. That's when the rubber meets the road.
We are going through 3 lessons. I have like 17 more.
It's not 3 lessons. 5. Yeah. I just typed it like this. It's all one lesson. I tried to divide it up. Stop. You look like you ate a lemon, Wyatt.
I wish I did.
I don't like this package.
Don't think that. Package not the problem.
All right.
Yeah.
Look at number 11 and look at the words below number 11. Remember, Haney, come to your seat. You don't get to sit beside Wyatt. Well, Wyatt's not done, unfortunately. He hasn't stopped whining long enough. Now he's whiny Wyatt instead of eager beaver. Okay. When you plug in a 0, you should get 0. That's what happens. All right, so really, numbers 12 through 15 are no different than what we've already been doing. So look at number 12 through 20. Yeah. All right, 15 was the requested one to do. All right. So I've been asked to find all the zeros given a 0. So it's given me a springboard here to start from to say, hey, I'll give you one of them, you find all the rest of them. But really that's what I've been doing because I told you if I had a factor, then I also had a what? A 0. So if I have a 0, I also have a factor. It goes both ways, right? So what this is really saying, this is saying that x plus 2 is a factor. Agree or disagree? Because I got to change that sign, right? Remember, whenever I find the 0, I change the sign because I set it equal to 0. So now I do exactly what I did for all the previous problems. I'm going to factor it completely. So to factor it completely, you're exactly right. I'm going to do synthetic. So -2. Don't need any placeholders here? 3, 2, 1 constant. Nope. 1, -2, -14, -12. Slade, you still doing long division back there, or are you picking up on synthetic with us? It's all right. There was a time when you said, I'm just doing long division. All right. 1, -2, -4, 8, 6, negative 6. What? You're adding. 15. 15.
Oh.
Wonder.
How do you get 8? Isn't it usually 2 times negative 2 times negative 10?
Yes. You always multiply by the number on the outside and then you add the column. So negative 2 times negative 4 is 8, and then I add that column together. Well, you can, but what I'm going to do is factor completely. You can put this on the outside with the same sign. What?
Oh, never mind.
You sure? Yeah. I was just tying it back to the other so you saw.
Oh, you have to do quadratic formula.
Do you? Oh my gosh, y'all. Calm down. The world.
You have to do quadratic
Okay. I'm going to factor completely. X plus 2. X squared minus 4x minus 6. The boys are restless because we have to do quadratic formula. How do you know you have to do quadratic formula here? Because my goodness, it's not factorable. Nothing in the world multiplies to negative 6 but adds negative 4, which means quadratic formula. Opposite b plus or minus the square root of b squared is 16. 4 times 1 times negative 6. It's not imaginary though.
What? Are you sure about that?
16 plus 24 is a positive number. Discriminant is positive. It means 2 real solutions.
Sure about that.
Oh my goodness. What's 16 plus 24?
Oh, like it is gonna be. Oh wait, never mind.
Minus a negative is plus a positive. 2 outside, what's inside? 10. I can divide everybody by 2. Square 5, square 10. 10. Don't do what's under the radical, only what's outside. 3 solutions, yes? 1, 2, 3. What?
It is nice.
Yeah, that's what I use. That's okay. So 3, degree is 3. 1, 2, 3, I'm good to go. You wish. Now what we're going to do before, right after our brain break is I'm not going to give you a factor or a 0,
What do we have to do? Find all
and you're
that?
still going to have to find them because I'm so mean.
We already do that.
All right. This is new.
Yeah, 2 times now.
So
Is this on our packet?
this is on your packet, actually. This is the rational zero theorem. So here's what a PRZ is. PRZ stands for possible rational. What do you think it stands for? What have we been talking about?
Possible rational.
Zeros. All right. So what this is going to do, this is going to give us a way to list out a whole bunch of possibilities that we're going to test until we find one that works. And by works, I mean find an actual 0. Now, what's rational mean? What's a rational number?
A number that is not a type.
Okay, that's irrational. Like not, it can be expressed as a what? A fraction. Okay, that's rational. Irrational are numbers like pi, square root of 2, that kind of thing. That have long decimals that never repeat. One third repeats the pattern though. And it can be written as a fraction.
Decimal would be irrational.
No.
Okay.
We always start at 0.
No, you should always start at 0. Okay, so let me tell you how we're going to do these. I feel like y'all are doing this on purpose to me.
Zero's not real.
No. Yeah.
That's what I thought it was getting to.
All right. Right. What is the leading coefficient here? What is the constant?
8.
Negative
Plug in the
8.
constant.
To find your PRZs, notice the very first one, it tells you just, guys, it tells you just to list them. PRZs are every possible combination of factors of the constant divided by factors of the leading coefficient. What does it mean to be a factor? Okay, or divides in with no remainder, right? So if I look at this example, we said the leading coefficient is 1, the constant is 8. What are the factors of 1? 4,
Nothing.
negative 1.
Oh, there's negative 1.
2 negative 1s together will give you positive 1. Okay, factors of numbers include plus or minuses with them, because the negative values also. No, even if it's negative, because a positive and a negative together makes a negative. Yes.
8 we can do.
And with negative 8, what are, give them to me in
Negative
sequential order. Plus or minus
Plus or minus 1.
1.
Plus or minus 2. Plus or minus 4. Plus or minus.
Does everyone agree that all I've done is list out the factors of the leading coefficient and factors of the constant? I've not done anything else. Okay. To find my PRZs, I take all of these factors and divide them by all of these factors. In this case, it's just one number, so it's not hard. Yeah.
Oh,
Not yet. Now what I'm writing now goes on the line. So now my PRZs, this goes on your line, are all of these numbers divided by 1, which is just itself, right? So plus or minus 1, 2, 4, and 8. That's it. That's all the PRZs for this particular polynomial.
But does that mean that all of them are? No.
Well, what's all of that divided by 1?
Oh, I thought you were like saying how many there were. 8.
Leading coefficient.
It says factors constant. So I thought that however many factors.
Is that better?
Yes.
So the next one, yes, for the, yes. Okay, so, well, not quite. Let me show you. Look at the second one. F of x equals 2x cubed plus x squared minus 4x plus 1. What are the factors of the constant? Plus or minus 1. What are the factors of the leading coefficient? Right? So my PRZs are going to be, here's where y'all are not going to be happy. All of these divided by 1. All of these, which just happens to be 1, divided by now 2.
Yep, they're angry. They angry now.
Okay, does everyone see how to list them? This is the easy part, listing.
Now the hard part is.
Let me give you another one. I saw a couple heads shake.
Now the hard part is.
So you take these and you divide it by every one of these. Every possible combination of these factors divided by these factors. Would it be what? You try this one.
Oh my. Now you see it. Now you see it.
What, yo?
This is just a separate example. We will. You don't have enough information to do 16 yet. All right, look at this one. This one's not on your packet, listed off to the side somewhere. All right. All right, so tell me what you're doing. You're finding the factors of 30, right? All right, so we got 1, 2, those are not the PRZs yet. That's just, okay. Now, to find the actual PRZs, which are still not the actual zeros, they're maybe zeros, maybe not. That's why we call them possibles. So I take all of these and I divide them first by 1. So it's just the same list. 1, 2, 3, 5, 6, 10, 15, and 30. But now I also have to take this whole list and divide every one of them by 5. 1/5, 2/5, 3/5. 1's already on there, so I don't need to write that again. 6/5. 10 divided by 5 is 2. That's already on there. I don't need. 15 divided by 2. And 30. What? This 15. 15. Oh! Gosh. And that's 3, and that's on there. You're right. I made it up. That's all the PRZs.
No, there's missing one. Oh wait, no.
Why do you only invent that?
I did all of them, but there's no sense in repeating. If you want to repeat them. It doesn't matter. It's just going to be more work for you to test. But whenever I got to 5, well, now you got to pick which one works. So this is where, look at your steps on here.
This is where we have to grind. You have to synthetically divide over and over.
You have to synthetically divide by these. Remember, this is plus or minus 1. So this is positive 1, negative 1, positive 2, negative 2. You're going to keep dividing until you find the one that works. What do I mean works? Ends up with no remainder. You will have, I can already tell you, you will have one on your test that is a double PRZ quadratic formula. I'm going to, after we do this, I'm going to show you a shortcut to help you choose the ones you want to choose. Okay. All right. Let's look at number 16 together.
How can you have an anger?
3 minutes.
We just took a brain break.
That's all you have to do?
That's how you list the PRC. You don't want to factor that one. I made it up off the top of my head. It's not going to come out pretty. You think so? How many solutions should I get for this before I start? 3, right? If you don't get 3, you've done something wrong. Go back, redo it. All right, first thing I'm going to do is list out the PRZs. So the PRZs for this problem, plus or minus 1.
And I found this one.
So sometimes it helps to come over here and write it the way we've been doing. 1 over 4. You're missing one. 1 over 2. Okay. What are the factors of 4? 1, 2, and 4. Okay, so now, step 2. Synthetically divide until you find one that works. All right, so watch what I do. I'm going to start with 1 just because I imagine that's where you would probably start. I do need a placeholder here. So for 0, negative 3, negative 1, 4, 4, 4, 4, 1, right? 1 actually works. Do we agree? Okay.
Oh, but if it didn't work, you'd have to do the rest of it.
You'd have to keep going until you found the one that worked. Okay. Okay. Now, understand where I am in this problem now. Now I'm to the point where I say f of x equals 4x cubed minus 3x minus 1. If x equals 1 is a 0, find all the other zeros. Well, we've already done that. So now it becomes the problems like we've already done. Factor it completely. So x minus 1 times 4x squared plus 4x plus 1 squared. Yep, that's what it means when you get a remainder, that you found a 0. Are y'all with me? I want you to see that up till here, that after that line right there, we're doing exactly what we've been doing. We just had to find one that worked. They didn't give me one that worked to start with. So now I found one that worked. Now I'm back to where I started. So now can you factor that? That is in fact. What? Once you find one, you don't have to go back to the possibilities. It's a perfect square trinomial. Guess what would happen? Guess what would happen if this did not factor again? If it was maybe a cubic or a quartic that wouldn't factor.
Then we have to do quadratic.
What if it wasn't a quadratic? What if it was a cubic or a quartic? I might have to do PRZs all over again because PRZs are just a way to factor. All right, but let's finish this one. Someone said this is actually a perfect square trinomial, and they're actually exactly right. Right? Or 2x plus 1, 2x plus 1. So that means my zeros are 1.
And 1/2 twice.
Negative 1/2 twice. And I'm glad you said twice because that means it's got multiplicity 2, which means it does what at the axis? It bounces at the axis. Everything you thought you would learn it for the test and forget it. But
We have to keep graphing. We're gonna have to graph with this.
I know. Right?
This is all leading up to curve sketching and freak out. Okay. Huh? No, but what you need to understand, this is multiplicity 2, which means it bounces. You don't have to write it down, but know it, because it's going to come into play again real soon. Odd multiplicity, or yes. Even multiplicity bounces, odd multiplicity goes through. Okay, let's do another one together, and then I'll shut up. Pick one. 17 through 20, pick one. 17. Hot tea on the flip. Do you know that song? Yeah, I love that song. Say it again. 2, 3. 18. But then I can't sing my song, Haney. Get real serious with me one more time.
We're doing 17, I'm already doing it. I've already started it.
18's harder.
I don't care.
Yeah, 18. 17.
I could actually group 17 the way it sits.
Yeah. 17, 17.
I mean 18. 18 I could group the way it sits.
Well,
And I wouldn't even
you can divide that.
I wouldn't even need a
You
PRZ.
divide it together.
Yeah, you can do it with them with 18. Oh.
Yeah.
Of course.
Without police.
On 18,
How can you come down?
18 you could slash it and factor it completely so you don't have to. PRZs are a last resort. They're kind of like quadratic formula. You only want to do them if you absolutely have to do them. All right, so 19. My directions for this are just to find the zeros. And I don't have anything given to me to start off with. So what I'm going to do is I'm going to see if I can factor it to start with, and I can't. This is a quartic. It's going to be kind of hard to factor. So what I want to do is list my PRZs.
You graded my quiz.
I graded everyone's quiz. I gave it back to you. I told y'all I was... All right, PRZs. What are they? Plus or minus 1. Pretty nice to have so few PRZs.
Not nice to have a fraction.
I'm going to start with 1 because that's generally where I start. 4, 3, 2, 1. Yep. 1, -1, -1, -1. Drop it. 2, 2, 3, 3, 2, 2. 1, 2, 1. Nope. 1 does not work.
Wait, why'd you put 1? Put 2 instead of 1.
Where?
That is right.
Where?
In the end, you multiply 1 times 1 and you got 2.
You are right, Miguel. You are right.
It is 2. No, it's not. It'll always be 1.
No. But I think this might be a double PRZ, which is a good one for us to look at. It might be. Wyatt, let's get excited. Excellent. Woo! Thank you, Emma. Bonus points for you today.
I found the mistake though.
Okay, Miguel, you too. You too.
You didn't teach me how to do it. You taught me like
What?
before the quiz, and I'm still understanding. Like you're fine. You're gonna do fine. I made it for real. Please let me know.
Don't. You're grabbing Sullivan.
Everyone knows now that she's about
Okay. Okay. Look. Can I factor the polynomial?
Yes, you can with group.
It's not going to group though. I can take an x squared out. I'm left with 2x plus 3, and then 2x plus 1, so the factors wouldn't match. Uh-oh.
I'm out. You probably could.
Do we have to PRZ again?
My focus right now is getting this one factored
Say
down.
if we PRZ
Yes.
not.
Just for the one, huh? I was gonna say, oh my gosh, please tell me I didn't mess up again. Okay, now for just the one, for just the one underlined in green, I'm gonna PRZ it again. 1
It's the same PRZ, by the way.
and 1/2. Okay. I've already used 1. Chances are it's not going to be 1 again, so I'm going to move on to maybe -1. But I'm not using this original one anymore. Now I'm just using this one. I use +1. All right, 2, 3, 2, 1. I hope this doesn't work. Oh, we keep getting very lucky. All right, so understand what this means. I've got the x minus 1. Now I have the x plus 1 times 2x squared plus x plus 1.
Hey, that is a perfect.
No, it's not.
So I would definitely.
Yes, it is. Okay, this is a double PRZ quadratic formula. That's when I told you that you will have one like this on your test. Double PRZ quadratic. It's really not. Once you understand what it is you're doing, it makes sense. Okay, so
What? Y'all, that's all I've written so far for this problem. Y'all cannot have. Well, all we gotta do is solve it now.
But that's the problem.
Oh.
You gotta do
The back's blank just for you.
The
back is blank just for you.
are you for real?
Yeah.
Yes, we do. Because it's a quadratic. It's a quadratic.
Miguel. I did get you quadratic.
That's what I'm saying.
B squared minus 4 times A. I spy a complex solution and imaginary solution. 1 minus 8.
And it's stuck that way. That's great.
I'm dealing with you, Marky.
You forgot the negative. You forgot the negative. You forgot the
I put the I. Oh, yeah. Thank you, Miguel. All right. 1, 2, 3, and 4. I have all 4 solutions. It is a degree of 4 initially, and so it works. Okay.